screen over to Eugene. And thank you so much, Eugene, for taking your Saturday night to present for our virtual chapter. We really appreciate that.
It's my pleasure.
Okay.
All right. Mm-hmm.
Yeah, now we should be able to see your screen.
Yep. All right. And, all right. You able to see the slides?
Yes.
Great. All right. Oh, there we go. All right. So we're just gonna dive in. We'll have plenty of time for questions at the very end of this. But this should be a really interesting presentation. And again, I'm very happy to be presenting to the user group, and I'm glad I can help everyone out. So my name is Eugene Meitinger. You can find me on Twitter at SQLgene. I also have a blog at SQLgene.com. And if you go to /PowerBI, I've got a list of resources for learning about Power BI because they're kind of scattered. There's resources everywhere. But this presentation is going to be about Power BI internals, and we're going to actually have a bunch of demos. We're going to do some deep dives, and we're going to talk about some of the stuff that you usually don't hear about when you're learning about Power BI because it's just a visual-based tool. Quickly about me, I work as a business intelligence developer or a business intelligence consultant, depending on how you think about it. I work for a consulting company. I'm certified in querying and administering SQL Server. I am going to be presenting at PASS Summit and talking about PowerQuery. So I'll be doing an introduction to M language or PowerQuery, which is really exciting. I'm very excited to be presenting at PASS Summit. I'm also a Pluralsight author. So I've done a presentation on Power BI data gateways that's up on Pluralsight. It's an hour and a half long, and I'm pretty proud of it. I've been working at a company called All Lines Technology /Landtech for about 5 years now, going on 6. But the most important part out of all this is the fact that 5 years ago, I didn't know the difference between a stored procedure, a view, and a function when it came to SQL Server. You know, the job said it was going to be .NET/SQL, and I thought, great, this is going to be 80% .NET, 20% SQL. I took a database course in college. I got this. And it turned out that the job was very different. It was very much more reporting. It was very much more BI. It was very SQL heavy, and they didn't have a DBA. And the reason I bring all this up is 5 years ago, I was not giving presentations on virtual groups online. I was not presenting at PASS. I was new to the idea of user groups at all or virtual groups at all. And I went to the SQL Saturday in Pittsburgh, and it was really, really cool. And I went to the after party, and that was my mistake because I got cornered by Gina Walters, who was running the group, and Rick Hygus, who was a former PASS board member. And they said, you should present. And I said, I'm not qualified. And they said, you should present anyway. And so I did. And I did a presentation on execution plans. And for me, presenting like this has been really, really beneficial. It's helped me learn. It's helped me become a better communicator. It's helped me give back to the community. And I implore all of you, really consider presenting because it's a wonderful way to learn. It's a wonderful way to give back. And groups like this are always looking for new speakers. So please definitely consider it. So enough about me. Let's talk about this presentation. So why did I decide to do a Power BI internals presentation? Why did I pick this topic? So one of the things that I think is important when it comes to Power BI is to sell the steak, not the sizzle. So that's a marketing slogan kind of in reverse. Because normally what they say is if you've got a commercial for Applebee's and they really want to bring people in, you don't want to sell pictures of steak. You want to sell the sound of the sizzle as it's cooking, or something that's evocative of the smell or the taste or whatever. And I think, unfortunately, that gets taken a little bit too far when it comes to Power BI because it is a graphical data visualization tool. And so as a result of that, a lot of the content focuses on the visualization. A lot of the content focuses on how it's designed for business users, and you can do drag and drop, and it's so easy to get started, which are all great things. But there's this gap. There's this gap between what you can do with the dashboard in a day type training and the real power and some of the underlying mechanics of Power BI. With SQL Server, there's a lot more focus, if you're a DBA, on internals. There's a lot more focus on how it works, because as a DBA, you really need to understand the inner workings. But with Power BI, you can get really, really far with drag and drop, or as my boss used to call it, poke and hope, right? Where you change some stuff and you hope it works. So I wanted to try and talk about kind of the meat, so to speak, of Power BI. And it really is a lot more than flashy graphics. It's a lot more than just graphs and charts. I mean, if you just want graphs and charts, it may make more sense to focus on something like ClickView and Tableau. Tableau is, in very many ways, the gold standard of data visualization. And it's something that Power BI, in a lot of ways, aspires to. But Power BI isn't competing on the exact same playing field. Power BI is an ecosystem. It's a bunch of moving parts that come together, and we're going to talk about most of those parts, at least in brief, and we're going to have demos relating to those different parts. And then kind of just the last reason of why I decided to do a presentation like this is that Power BI is a challenge to learn. I personally had a lot of challenges when I was trying to learn Power BI, in part because it is a new technology. Power BI as it was 3 years ago, totally different. Power BI as it was 6 years ago, pardon me, is, you know, a completely different set of technologies. Even though a lot of the same engine work is used, 7 years ago, 6 years ago, Power BI was just this conglomeration of Excel add-ins, and now it's this software as a service tooling. So it's totally different. And while I think it's starting to get better now, 2 years ago when I was looking into this, there just wasn't much training at all. I really suggest you get a book on a lot of this stuff, because it's hard to find good content. And I've got some resources listed at the end of this. But that's why I wanted to do a Power BI internals talk. I thought it'd be something a little bit different. So I'm going to go into some of these basics just real quick. I'm going to try to skim over them, because the organizers told me that all of you likely have seen a lot of Power BI content through this group or in other places. So I may go through some of these things quickly, but again, we'll have a lot of time at the end for questions if there's anything that is a little bit confusing. But Power BI, just very briefly, is cloud-based data visualization and data modeling. And its primary competitors are Tableau and ClickView. So when you think about what does Power BI do, if you're familiar with Tableau or ClickView, those are good examples as competitors. It's not so much a competitor to Crystal Reports or SSRS, because those are more operational reports. Like I said, Power BI used to be a set of Excel add-ins. It used to be Power Pivot, PowerQuery, Power View, which is deprecated, and Power Map, which was a very targeted add-in for mapping functionality. And so where I'd say that Power BI shines is when you're dealing with KPIs and dashboards. You know, you want to sum up a bunch of data. You want to look at one screen of glass to see how the company's doing. It's good for self-service analysis, where you don't want IT to get in the way of everything. It's great for pulling in data from a bunch of different sources, and it's software as a service business intelligence, because you're paying a certain amount per month per user for this infrastructure, instead of having to have it all on premises and manage it yourself. So what are we going to cover? These are the different parts that we're going to go over, and this is kind of the flow of data if you think about it when dealing with Power BI. So it starts at PowerQuery, where we're acquiring and cleaning the data, and then it goes to DAX, where we model the data, we add meaning, that sort of thing, and this is done in Power BI desktop tooling. Then the data gateway is used to suck that data up and send it out to the cloud, where it's stored in the Power BI service. And then finally there's the visualizations layer. So we're going to have pieces on each and every one of these, although we're going to go into depth in some of these more than others. So very quickly, Power BI Desktop, you've probably used this before. It's a free desktop report authoring tool. You're paying for the infrastructure, and what they want to do is they want to give the tooling away for free. They want everyone to use it. It's just like selling shavers versus razor blades. They want the shaver to be really, really cheap, so they can charge you a lot for the blades. And this is, you know, very different from some of the previous licensing models. Well, with SSRS, the report making tooling was still kind of free, but you're paying a ton for SQL Server licenses. SQL Server licensing is really, really expensive. So Power BI Desktop is used to make the reports. It's not really designed for report viewing, right? Again, they want you to go online, they want you to go on the Power BI service, and it uses a file format that's .pbix, and we're going to actually dig into this file format and look at some of the internals to see what's going on there. But for the maybe two of you who haven't done anything with Power BI Desktop, this is what it looks like. Nothing too fancy here. But let's talk about some of the internals. So the PBIX format, it's just a zip file, and we're going to see that we can actually turn it into a zip file to take a look at what's inside. Because it's a zip file, it is absolutely terrible for source control. And so if you're a developer, this isn't going to be all sunshine and rainbows here. You're not going to be very happy about it, because if you think about it, the ideal with source control is you have a bunch of flat text files, because source control can compare the minute differences between those and just store the deltas. Well, when you have a zip file, it might as well be a giant binary blob. And whenever you make changes to a zip file, because it's compressed, those changes can have cascading effects. So you may have changed just a couple bytes, but it could change the entirety of the file because it alters the way it's compressed. In this file, there's a bunch of different subfiles, and there's our data model, there's our PowerQuery queries, there's our data visualizations, and then there's a couple other files, and we'll be able to actually see this. So the first demo is we're going to actually crack open a PBIX file and take a look at what's inside, so you have a better idea of that, and you see that it's not as scary as it might seem. So what we can do, so I've let me make a copy of this. I don't want to mess it up. So I'm going to make a copy of this. So this is a Power BI file. It's a .pbix, as you can see there. And so if I open it up real quick, we can see that it's, you know, completely functioning. I've got some very basic charts and graphs, and I've got my different tables. I've got just two tables here, which we're going to use for some of our other demos, but you can see it's a regular Power BI file. So if I close this and then I just right click and say rename, I can go over here and say, oh, this is not a PBIX file, this is actually a zip file, and it warns me. It says, hey, are you sure you really want to change that? That's probably not a good idea. And I'm going to say, yeah, that's fine, I don't mind. So if I open it up, now I can see there's a bunch of different files in here. And so let me see if I can, let me try and extract it all, because that's probably going to be the simplest thing, so that I can open some of this up. So let's extract all of that. And so first, let's start with our data mashup. So this is the PowerQuery stuff. So the DLLs, if you ever look at them, are called data mashup. Let me add word wrap to... and if we scroll down a bit, a lot of it looks like gobbledygook, and I don't expect any of you to actually be looking at the innards of any of this. But what you can see here is this corresponds to our PowerQuery piece. So let me make another copy of that and pull that back up so I can show you just real quick. So give me a second. So let me open that back up. So let's see, I'm trying to think. Okay, so we have an example here called fill column names. So if I go to edit queries and then I go to advanced editor, right? I can see all of the source code. So I'm going to search for changed type in our document there. So I'm going to say I want to find change type, and there we can see it. So again, I don't expect any of you to be fiddling around inside of this document. That's not the point. The point is that we can see what is here, how it's stored, and the fact that it's actually pretty accessible. The next one we're going to take a look at is this data model. So this is really interesting. So again, it very quickly, especially this one, kind of just devolves into gobbledygook, because it's actually just it's a binary stream and it's compressed. But we can see at the very beginning we've got some XML going on here. And I want you to take a look at this 140, this backup restore sync version. So this is really interesting, and we're going to have another demo relating to this in a little bit, because this 140 corresponds to the version of SQL Server analysis services that this is using underneath the hood. And that's relevant because we've got a demo where we're going to restore this data model to SQL Server Analysis Services 2017. And the version number for 2017 is 14 for historical reasons, because what happened was there was SQL Server 7 way back in the day in the 90s, and then the next version was 2000, but the internal version number after that was 8. And they've just been incrementing ever since. So SQL Server 2017, underneath the hood, it's version 14. But again, this is where all the DAX and all the data modeling is stored. You've got your compressed data as well. And it's really cool to be able to take a look inside and just poke around here. We've got some metadata. We've got some stuff about the layout. I think we can pull this one. I forget if we can. Yeah, we can see it's just a big JSON file. There's some other things too about some of the measures. I don't think I have any visualization stored in here, but if I did, then if there were custom visualizations, it'd just be stored as HTML, CSS, and JavaScript. So that's the first demo. I just wanted to show you that this PBIX file, this binary-looking file that looks like a black box, is actually a zip file with a bunch of semi-readable, partially readable files inside. You know, and it's nice to know that you can actually go in and poke around a little bit and see what's going on underneath the hood. So that's the first one. Let's see where we're at. Okay. So back to the presentation. So we talked about Power BI Desktop and the PBIX file. So that's kind of the base for what we're going to be doing a lot of the time. And the next thing I want to talk about is PowerQuery. So PowerQuery, they changed the naming. The language is called M, and the naming is now just get and transform data. And I feel very mixed about the new naming scheme, because on the one hand, I wasn't a fan of the marketing strategy of just slapping the word power on everything and saying, okay, PowerQuery, PowerPivot, PowerShell, PowerPoint, whatever. Oh, sorry. I apologize. I think I need to switch that. Sorry about that. But anyway, wasn't entirely a fan of the power everything naming, but get and transform doesn't really stick out. It's hard to refer that as a technical term. But PowerQuery, the M language, is a declarative language for your data wrangling. It's a macro language for cleaning up your data. So if you, anything, I like to say that if you could pay someone minimum wage to do it in Excel, you can do it with PowerQuery. So if you clean data by hand, this is a good tool for you. If your data, however, lives in SQL, there's a good chance that you may not need it. Half of the functionality of this just doesn't, it only makes sense if your data is in flat files where there's no structured formatting. But the very moment that you've got your data in SQL Server, for example, now you've got data types, you've got date time, you've got varchar, and you're specifying some of these constraints. It really makes sense if your data is kind of ugly. So what does PowerQuery look like? And again, I'm assuming that a lot of you have already played around with a lot of this stuff, so we're going to go over it kind of quickly. So here's what the code looks like, and generally you're not going to be messing around with this code, but here's what it looks like, and it's really just a series of steps. And if you look at some of the parts in quotes, you can almost see how these lines feed into each other one by one. But I really like to think of it like a recipe where we've got just a sequential series of steps as we're manipulating the data, and I'll show you in a demo what that looks like more realistically. Here's a quick picture of what the GUI looks like. It's designed to be very user-friendly. You can do 80% of what you're ever going to need to in PowerQuery from the GUI. Now, let's talk a little bit deeper about some of the stuff behind the scenes. So one of the biggest pieces of functionality is query forwarding when it comes to PowerQuery. So PowerQuery is pretty smart, and it can take certain steps that you apply and push those back to SQL. And this can really improve performance, because if you do something where you get rid of columns, where you filter by something, where you rename a column, where you concatenate strings, all of this stuff can be pushed back to the database engine, which is going to be a lot more performant, especially if you're dealing with filters. Now, the trick is all of the foldable items have to happen first. The moment you do something that the SQL engine does not support, then everything else after that's going to happen in memory and in PowerQuery, and it's going to be less performant. But like I said, things like string concatenate filtering, those can be pushed down. Things like split by delimiter that don't have a native SQL option cannot be pushed down. They can't be folded into the query. It's also worth mentioning that query folder is available for other things. I believe even like Active Directory or Exchange, if I remember correctly. But my experience is generally with the SQL piece. If we end up running short on time, if we end up having some extra time, I can do a couple demos relating to this, but we're going to move on for now. Another one of the internals pieces when it comes to PowerQuery that I think is really interesting is lazy evaluation. So there's eager evaluation and lazy evaluation. And this is also something where if we have some extra time at the end, I'll go into a demo. But put simply, expressions are only evaluated when they're needed. And so if you've done any programming with Lisp or F# or Haskell or any functional programming language, there's a good chance that you have some experience with this. And so what it means is that just because you have some code in there doesn't mean it's going to get used. And just because you're doing certain transformations, if you're not using those columns, then that code may never run. And so one of the things, the order of your code only implies the order that it runs in. It doesn't force it. So if we go back to the code to take a look at an example, you can see these lines are implying the order of the transformations. But I could literally take all of these and flip the order, and so I could have it at the very bottom. I had it so that change type 2 transformation happens or is in the list first, and just completely reverse the order, and it would have no impact on the performance, because the part after the word in at the very bottom is what it's pulling. It's saying, okay, I need this, and so then it looks to see where that's defined and see what pieces it needs. And so it's a lot more that it's pulling the data as opposed to it being pushed to the display. So let's take a little bit quick look at PowerQuery. And again, there's a good chance that many of you have done stuff with this, but just to show you real quick. So let me show you a mock-up of some really ugly data in the kind of area where PowerQuery shines. So this is just some dummy data that I made up, and it simulates stuff I've seen in the wild, where it feels like people are using Excel more like an artistic canvas than they are a data store. Or you've got data in what people like to call spread marts, where it's just on these spreadsheets where there's, you know, financials 1, financials 2, or sales quota old, or whatever, where you've got 5 copies of the same file and you've got people manually manipulating and all this kind of stuff. So this is not an ideal way to structure your data. We've got headers there, we've got blank spaces where we don't want them. It's just ugly. And I've had to work with this kind of data before for actual commissions, and it's a pain to get into something that you can really manipulate. But PowerQuery is really great, because if we go ahead and open one of these, we can see, if we take a look at the navigation piece, this is kind of what we have in that Excel sheet. And you can use the ribbon to make tiny little changes. So if we want to remove those top 2 rows, right? I could say remove rows, remove top rows, and I could say I want to remove 2 rows. Now I already have steps here, so it doesn't want me to do that a second time because it's going to break things. But if I click ahead, we can see I've removed those rows. I can get rid of blanks. Over on the left, we've got these categories and subcategories where there's blanks, so I can fill them down. I can say that first row is a bunch of headers. I can unpivot these columns, split them, and then later repivot them. So now I've got year as its own column, and I've got 3 columns for the different types of information, for the forecast, actual, and variance, or something like that. So this is some of the really cool power of PowerQuery. It can do a lot of data cleansing for stuff that you would normally do manually. And again, you're going to be dealing with the GUI most of the time, but if you want to just see what's going on here, it's very easy to take a look. And you can make custom functions. You can write this all by hand if you wanted to. But I just want to show you real quick some of what PowerQuery can do. And like I said, if we end up having some extra time, I've got some other demos relating to this and some of that extra functionality, but that's kind of the gist of PowerQuery. All right. Okay, so now let's talk about DAX. So the DAX language is a data modeling language, and I think it's really important to make a distinction between M and PowerQuery and DAX, because it's not always clear where to use what. And one of the ways that I like to make that distinction is, I said, you know, if M is when you'd pay someone minimum wage, M for minimum wage, you know, $8 an hour, $750 an hour, whatever, to do cleanup in Excel, DAX is what you'd pay someone $30, $40 an hour to do, because it requires an understanding of the business, because it requires an understanding of the end goal. This is where we take that raw data that's been cleaned up, and we actually add meaning, we add business logic. Another way that I like to think about it is my wife and I like to cook occasionally, and usually I'm her sous chef, right? So I'm the one who's chopping all the vegetables, you know, cleaning stuff up, preparing things, mixing things, but she's the one who actually puts everything together. And so M is where you chop your vegetables, and DAX is where you actually put everything together and you cook it. That's just another way I like to think about it and figure out, okay, where's that dividing line? So what is DAX good for? In my mind, there's two things that's really good for. It's good for aggregates and it's good for filtering. And if you're not aggregating and you're not filtering, you probably shouldn't be using DAX because it's not a good fit. So I like to think of it as a learning curve problem. And there's a link at the bottom. I have a presentation I did about DAX in more detail. But one of the challenges is you start learning about DAX, and you start learning about scalar functions and calculated columns, and you go, oh, this is just like Excel, or oh, this is like SQL but different. And then you run into a roadblock, because the learning curve shoots up dramatically once you start dealing with filters and measures, and especially once you get to evaluation context. And then it gets a lot simpler. And so we're going to talk about some of the stuff about how the DAX engine, the Vertipaq engine, works underneath the hood, so that you're a little bit better prepared for dealing with this stuff. Because it's a completely different type of engine than a relational database engine like SQL. It's a columnar engine. So let's talk a little bit about this. I use the term DAX engine, Vertipaq engine interchangeably. They technically have slightly different meanings. DAX a little bit closer to the user, and it deals more with processing the formulas and the expressions, whereas the Vertipaq is kind of the heavy lifting piece that does a lot of the work. But either way, when you're dealing with DAX, you're dealing with this engine, and this runs entirely in memory, and it's a columnar database, which means that the data is stored as contiguous columns of information. And so if I have a column for sales total, all of that data is stored in a row. And I've got some visualizations to help explain some of that, but that means that if I just want to do a sum of sales total, all that data is all together, so it's really easy to just kind of pick up and aggregate. Additionally, the data is encoded and compressed, which means that you can fit millions of rows of data in the memory on your laptop. If your data has a lot of repeated values, you can fit a lot of data in a small amount of memory. It also means that it's going to have much faster results. What you're really doing is you're saying, I want to take up as little memory as possible, and I'll use a little bit more CPU to deal with it, but it's worth it. And some of these encodings and compression strategies take advantage of the fact that everything's stored in columns in ways that you could not do it if you were doing with a row store database like SQL Server. So when you're dealing with DAX and you're dealing with the Vertipaq engine, columns are kind of the fundamental unit of measure that you're working with. So like I said, it stores the data as columns, and it's super efficient for simple aggregations because it doesn't have to look at anything else. Or even if it's dealing with some filtering, it's able to basically, it's as if you had a bunch of light switches, and it's able to go through the column for the one that you're applying the filter based on. Like let's say state. You know, I want to filter on everything in Pennsylvania. And so it's able to basically go through each row and say, okay, this one's going to be good, and this one's going to be bad, and this one's going to be good. and do that very efficiently, and then apply that as it runs through the other columns. So if you want to take the sales total for all the sales in Pennsylvania, it only has to look at 2 columns of data, and it can do that very efficiently. A lot of these aggregate functions, when you're dealing with DAX, are going to take columns as parameters, and it's just in general optimized for single column operations. And again, if you watch that that video that I have on, and it's called an advanced introduction to DAX, it goes into a lot more detail. But we're going to talk more about internals. So, like I said, you've got your data, and in a traditional database, it's stored in rows. And so what that means is that these pieces of information would be stored contiguously. Blue would be next to Pennsylvania, would be next to the number 1. And in SQL Server, that's on these 8 kilobyte pages. And so it has to pull all that information. So let's say I just wanted to get the total quantity. I just want the sum of all the quantity. I don't care about anything else. Well, in a row store database, I have to go row by row by row to manage all the data. Whereas when you're dealing with DAX, your data is actually stored as separate columns. And so I can just grab that quantity column and be done with it. So that makes a big difference for performance. What it also means, for reasons I can't go into a lot of detail, the more columns that your formula uses, the worse your performance is going to be. So you really want to be careful about that. It's just something to bear in mind. So now, we talked about how everything's stored as columns. Let's talk very quickly about compression and encoding. So the data is compressed and encoded so that it takes up the minimum amount of space necessary. And this is important when you're thinking about, okay, what data do I want to pull in? And we're going to see how having wide tables with a bunch of columns screws up run length encoding and can really negatively impact your compression and potentially your performance. So value encoding, that's basically, think about if you have an account number with a healthcare provider. I've got an account number that's like 8,050,625. I severely doubt that in this little county of Beaver County in Pennsylvania, they have 8 million customers. I don't think we have that many people in Pittsburgh. Instead, I think they're using that number as part of an identifier for which department the account is from and all that kind of stuff. But imagine you said, you know what, I don't want to store all that information for every single person. I'm just going to subtract 8,500,000 from every account number and just store the delta. That's what value encoding is. So if you have a narrow range of integers, it'll store everything as the difference. Great. Dictionary encoding is whenever you say, you know what, let's say I've got a customer named Punxsutawney Phil. That's our groundhog here in Pennsylvania. It tells us if it's going to have a winter, if we're going to have a winter that lasts a few extra weeks. So Punxsutawney Phil, it's a long name. Instead of storing that name maybe 50 times if there's 50 transactions related to this guy, instead, we'll store it in a dictionary and store the number 1 50 times or 2 50 times or whatever. So it's like a hash map or a dictionary. It's a lookup kind of system. And so if you've got these repeated values that are very long, they get replaced with integers. And then the next one, and this one we're going to go in a little bit more detail, is run length encoding. And the whole idea is that if you have a run of values, a set of values sequentially, you can just store the length of that run. So here's an example. Let's say we have that column of colors. And again, we couldn't do this if we were storing things as rows because we wouldn't have repeated values in a row, generally speaking. But as a column, we have a lot of repeated values, especially when you deal with state or city or country or a last name or whatever. And so here, we've converted blue to blue 1, green to green 2, and red to red 4. So we don't have to say red, 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 red. Now, red's pretty short, but again, imagine it's Punxsutawney Phil or something like that. This can be a lot of data savings. And the key thing here that I said before is that it relates to sorting. And all of your columns, even though they're separate, have to be sorted in the same essential order. And so as a result of that, the more columns you have, the less the columns that are sorted last are able to take advantage of this kind of compression. So let's take a quick look where we don't have a ton of time, but I just want to show you just real quick the impact that that can have. So we're not going to dig too much into it, but I just want to show you I've got two documents here. One I've called incremental, where it's just the number 1 through, let's say, 100,000, maybe a million. And then the one that's called repeated is the same thing, but it's just the same value repeated, right? So this is an extreme example of repeated values and compressibility. Now, if we're just dealing with the CSV files for these, we'll see, let me close that. We'll see that the repeated one is actually bigger than the incremental one. But, and here's the interesting thing, if we open up that incremental, so it's going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. We open that, we have that stored in Power BI Desktop. Then we can see the data here. But if we look at the data size, an empty PBIX file is 150 kilobytes. This incremental one is 15 megabytes. But the one with the repeated values is only 132. So what that means is it was able to compress 9 megabytes of raw data into about 20 kilobytes of data because it's repeated values. Whereas for the incremental, it took it took 8 megabytes and ended up blowing it up to 15. Now, again, this is a very extreme example, but it serves to show a point that if you've got repeated values and you have just a few columns, the DAX engine can compress that and work on it much faster. And that's part of how it can fit millions of rows on your desktop when you're dealing with, say, Power Pivot in Excel, for example, as opposed to, say, just Power BI Desktop. So that's the compression piece. Let's see. All right, we've got about another 15 minutes. Okay, so the next piece, and I'm going to go straight back into the demo, so I'm not going to jump into the full slides. Something I want to communicate is the Power BI engine is the same as SSAS Tabular, literally the same. There's some internal differences a little bit, but just to show you, so let me close this. And so we've got Power BI Desktop up and running, right? Now here's the fun part. So what I'm going to do is I'm going to run some code that I have to find out what port this is running on in the background, because it's running a copy of SQL Server Management Studio. So what I can do is I can just paste that in. Nope, I don't think I copied it. Hold on a second. I'm going to paste that in. Okay, and so my process ID is 9996. And so what I should be able to do is I should be able to find the port number. So it looks like it should be 5562. So let's see. So let's see. I should be able to, this query is for a different demo if that comes up. 5562. So I'm pointing to localhost. I'm pointing to 127.0.0.1, which is here. 62. We'll connect. And would you look at that? We're actually able to connect, and we have this weird named database. And in that weird named database are oh, those are connections. We want tables. And so I can actually look at it, and I can run, I should be able to run a query against it. Evaluate financials. Query, execute. Oh, I'm probably not spelling that right. So, this is the danger of typing in demos.
I think you're missing an N.
Yeah, I believe it. But we can see that that worked. And actually, if I just drag
Yeah.
and drop.
Mm-hmm.
Never type in demos. But if we execute, we can see what is
Missing a bracket.
thank you. Let's try that again. You know what? I'm not even going to worry about that. But you get the idea there. And we don't have time for it today, but actually, well, I can connect to this with Profiler. I can connect to this with Excel. You get the idea. So behind the scenes, we've got a copy. If we look here, MSMD SRV. That's Microsoft. I think it's multi-dimensional server, something like that. Even though this is tabular. But that's basically SQL Server analysis services. So that's just something really cool to understand, is that anything you can learn about tabular and SSAS, 90% of it applies. There are some difference in the internals. There are some. Okay. There are some differences in the internals when you're dealing with like dynamic management views and some of those things. But otherwise, it's largely the same. Also, as you noticed, those table names are GUIDs. Additionally, it'll make tables. If you do stuff with dates, it'll make these shadow date tables as well. So that's just something to be aware of. Okay, so the next part. So you've cleaned up your data with PowerQuery. You've added meaning with DAX. So what's next is the data gateways. So data gateways, they allow you to access on-premises data. There's two types. This technically needs updated because there's on-premises data gateway and then there's on-premises data gateway personal mode. They've gotten rid of the personal data gateway, but it's still functionally the same. The personal data gateway is basically for stuff that you would access as you. It's not really good for production. If you're interested in knowing more, definitely check out the Pluralsight course that I have on this. And then there's three query modes. So there's import, where the data gets pulled into the Power BI service directly. There's direct query, where the DAX formulas are converted into SQL queries, which is really cool. And if we had time, I could show you how it's able to push down filtering and do a bunch of these really cool things with that. And then there's live connections, where it's basically sending those queries to an SSAS data model directly and only sends back the results. So the data gateways are how your data gets from on-premises to the cloud. And speaking of the cloud, there's Power BI service. And again, I'm going to assume that most of you know about this already, but it's basically cloud BI software as a service. This is what it looks like. Now, one of the interesting things, which you can dig in more, is it's built on Azure. They really did dog food it, so to speak, which is a really weird idiom, because it implies using, it means like to use your own technology, but it's a silly idea because it's implying that people at dog food companies actually eat dog food to test it out, which is just goofy. But it's a bit of an idiom. The whole idea, though, is that they're using Azure. Everything's built on Azure. And they have a really great security white paper that goes into a lot of detail. So I don't have time to go into all this. You can read the white paper, but it's really cool that they use Service Bus to help shuttle the data between your gateway and the Azure cloud, and then everything's stored either on blob storage or in Azure SQL database, and they've got this web front end that helps shuttle things, or helps display some of that information. One other piece I want to let you know, which is really interesting and can be a gotcha. Your data, you can go to the About and see your data is stored in a specific data center. And so it doesn't change. And it's dependent on basically whoever signed up first with Office 365 or Power BI. And so if you have someone who's in Singapore or something like that, but most of your people are in the United States, and the tenant was set up in that area, it's going to be in whatever the closest data center is. So that's just something to be aware of. The visualization engine is based on HTML, CSS, JavaScript, and the D3 visualization engine, and they've made some changes to that. If we have some time, I can show you that the visualization files are also just zip files, but it's just JavaScript. It's JavaScript, HTML, and CSS. And you can even make your own visualization, although from what I understand, there's a lot of work involved with that. This picture is a little bit old, but I still like it because it shows you all of the custom visualizations that are available. But Microsoft decided they're going to move everything to the Office store. Now, I have mixed feelings about this because I thought it was really cool to see all the different options very cleanly, and instead it feels like they're trying to treat these visualizations like apps, which isn't really the right level of granularity in my mind. But I can see the value of having a video introduction and pictures and reviews, but hey. So we've got another 8 minutes, and I've got at least one or two other demos that I want to show you before we kind of wrap up. I don't think I need to show you here opening up a visualization. It's just like the other one, you just rename it. But there is one demo that I absolutely do want to make sure that I show you because it's really, really cool. So before I told you that this data model file, right? Well, this is how the data is stored. And I also told you that Power BI, in large part, is just SSAS, SQL Server Analysis Services, underneath the hood. So here's the cool part. Again, this version number corresponds to SQL Server 2017. So what I can do is I'm going to copy this, and then I have a virtual machine that I've set up in Azure. And I went ahead and installed SQL Server 2017 Community Technology Preview 2, I believe. You have to install it manually because Microsoft's really good about having these different templates available online to play around with, but for whatever reason, the only SQL 2017 template they have is Linux, because they really want you to try Linux. But I went ahead and installed it, and so I've got this data model file. Oh, you know what? I need to rename it on my personal machine first, because I can see the extension. So I'm going to rename this .abf. Now, I don't know exactly what that stands for. I think it's Analysis Services Backup File, but it's the type of file used to back up SQL Server Analysis Services databases. So now if we go back and we copy this file, and then we copy it to the backup folder for Analysis Services, right? And then we say, you know what, I want to do a restore, and there's our file, and I can just tell it okay, and I tell it refresh, and now I've got our information. And here's one of those like weird shadow date tables that I told you about. But I know when I tried it before, I was able to actually run evaluate against it. But let's just see if it works or if I just can't type worth anything. Because this should work. This worked about 2 hours ago. Why is it saying it's not about?
I think your financial, you're missing another N.
Oh, all right. Thank you. You know, this is why Saturday Night SQL shouldn't be a thing, because I can't type after 9 o'clock apparently. So let's.
Sorry.
There we go. No, it's fine. All right, there we go. Thank you. I do appreciate the help. All right, so we can see our data. So that's one of the cool things is literally you can take this file and load it into Analysis Service 2017. Now, 2 words of caution. 1, this is extremely unsupported. If Microsoft finds out that you watched this user group and you thought, oh, this is a great idea, and then you did it, they're not going to support you. 2, recently, I think in the past couple of months, they added support for directly importing the model in a Power BI file to Azure Analysis Services in the cloud. And so there is a supported way of extracting that data model, but I don't believe there's any currently supported way to do it for on-premises analysis services. But I just thought this was one of the coolest things, the fact that it literally is just SQL Server Analysis Services under the hood. Again, there's some things that might be different, but in large part it's the same thing. And so then the last piece that I just wanted to talk about, is just some resources, kind of real quick before we open it up to questions and that sort of thing. So there's a really great Pluralsight course by Stacia Varga about getting started with Power BI. There's an edX course, which I found to be really useful. It really helped things click for me in learning how to use Power BI. There's two great books out there. There's Power Pivot and Power BI by Rob Colley and Avi Singh. There's Applied Power BI by Teal Lechev. And then I don't have it here, but Marco Russo and Alberto Ferrari have the definitive guide to DAX formulas, and it is a must-read if you're going to be dealing with a lot of DAX. There's some Power BI content officially on YouTube, which is really helpful, as well as some virtual chapters. In addition to this one, the Past BI virtual chapter tends to have some presentations. And then, like I said, I have a list of resources as well. So those are all some very good resources to definitely check out. All right, so that is the main presentation. And so now we can start taking a look at maybe some of the questions that popped up. Okay, so we had a question: can Power BI connect to Postgres SQL? I am 99% certain that it can. I know it can do it for MySQL, and let's see if it's in the list here. It is. Now, be aware that whatever machine is accessing this data needs to have the PostgreSQL drivers and I think ODBC connector installed, which means not only do you need it installed on the machine that you're doing the development with, you also need it installed on wherever you're going to have your data gateway when you're dealing with stuff in the cloud. So you definitely can do that. They're adding different types of connectors all the time. There's also just a generic ODBC connector, if I recall. Here we go. So you can even, in theory, talk to just anything over ODBC. So just something to be aware of.
Eugene, do you mind to go over some of the demos? You said if we have time, we'll do it.
Yeah, absolutely. Yeah, not a problem. Just want to make sure I didn't cut into too many questions. So yeah, I have a couple other kind of demos real quick. So let's do those. Some of these are going to be a little bit more freeform, everyone. So just be aware of that. So may have some more demo issues, but we should be good. So let me first I will show you something interesting about direct query, right? So let me pull up Power BI. So I'm gonna run Profiler, although really Profiler's been replaced by extended events, but again, just for something quick and dirty, I'm gonna run a trace against my copy of AdventureWorks. Well, actually, yes, the entire server. And so we're going to do get data, and then we're going to do database SQL Server. And I'm going to do localhost, and I'm going to say direct query. And one of the interesting things you can see is that well, let me actually try and pick one. We'll do sales detail. That should work. It's interesting because it's accessing a bunch of schema information to see like what the data types are, what foreign key relationships there are. But here we can see, okay, here's a little bit about this direct query piece. Now, let's say I do decide to load this data. Now I should be able to tell it to take up half of the screen. And I want to take order quantity. Okay. I'm going to take order quantity. And what we're displaying doesn't matter. I just want to show you some of the neat functionality. And we were to, let's say we were to add a slicer. And I'm going to do that based on, let me see what my options are for product ID. That should work. So now here's the cool part. Let me see if I can get this a little bit bigger so you can see. So it's kind of hard to see, but I picked product ID of 716. And what it did with direct query is it applied that filter, right? Not only that, but if I were to have some DAX formulas, it's going to push down whatever it can, and then it'll do the calculations. So this is really interesting for a couple of different reasons. One, let's say you have a 100 gigabyte database. It won't be feasible to export all that data to the Power BI service. You can only have up to 10 gigabytes per, I think, user workspace, and then I think 1 gigabyte per file. But instead what you can do is you can have direct query where it's running these queries automatically. And if I actually, let's say we bring in another table, right? This should work. So I've got the detail level. So, oh, that's, sorry, localhost. Something else to be aware of is once you've picked a specific mode, you can't mix and match. So be aware of that as well. But if I say, okay, I want sales order header, I'm going to load that, and then I'll put same, hold on a second. I have to go through this, I think. Okay, let's see if that works better. Otherwise, I'll restart it because it needs to be the same data source. And it can only be one database at a time as well. So let's see if that works or it's being cranky on me. Okay, let me restart that so I can show you, because I want to show you how it applies inner joins, or just joins in general, I mean. Although you can tell it to do inner joins for even better performance if you understand exactly how you want your data working. So, all right, we're going to say get data. We're going to go back to database, SQL Server, and we're going to say direct query, localhost. Oop, it's late. Localhost, AdventureWorks, 2014. All right, so that should work. Okay, great. So now what I can do is I'll say I want detail and the header. And let's take a look and see if it okay, so it automatically identified this relationship. And so something actually really interesting to see here, do you notice how it says where 1 equals 2? Something interesting is it'll do little checks to make sure that the structure matches the way it intends. So this will never return any rows, but it will confirm that all those columns exist there, right? But let's clear this out. And I want to show basically that it's going to do a join for us and is able to take advantage of the structure of the SQL database. So we will do order quantity again. So let's see what it did. Okay. Okay, so it understood it didn't need to do a join on that. Let's see if we can force it to by pulling out something with the header as well. I may not be able to get this exactly working with the demo, but that's okay. Oh wait, I could apply a filter. Oh, let's see what it did. Yeah, you know what? I'm going to apply a filter. That'll force it down. So let's see, salesperson ID. We want that to be a slicer. There we go. Okay. So now you can see it's got sales order detail, it's doing a sum, and it's doing a left outer join on sales order header. And so this is the cool thing about direct query is it's able to apply whatever filter that we gave it, it's able to join everything, and it's able to query your terabyte-sized database if you want. So that's the cool thing about direct query. So that's that piece. We don't want any more traces right now. And then I had a couple ones quick about query folding. Actually, yeah, I guess we still want the, yep, sorry about that. Guess we still want profiler for the one about query folding. So let's pull that up. So the whole thing with query folding, if I edit the query, I've got my source where I'm just pulling from sales order detail and I'm pulling everything, right? And I've removed some columns. I've filtered rows based on sales order ID, saying I want everything less than 55,000. And let's say I even want to make a new row, or make a new column. Add column. And I'm going to do column from example, which is a really cool piece of functionality because you can just type in kind of what you want. And it's usually smart enough to figure out what you're doing. Let's see. All right, yeah, no, perfect. So I created this combined column, right? And then we're going to add one more piece, something that can't be pushed down. So we'll add the split by delimiter. So we're going to say, oh wait, I want to actually split this. Okay, so now I'm going to hit close and apply. Oh, I need to connect to SQL Server. Okay, great. So I'm going to hit close and apply. And we're going to see that it's folding down a lot of this stuff. So here's the query. And the way they structure these is so goofy because they give them these names of like underscore, which I don't get. But if we think about the steps, if we go back to the steps that we had, we can see that we removed columns, so it's only grabbing the 3 that we need. We filtered rows, which corresponds here. We've concatenated some detail and produced this weird column name, or not weird column name, but this combined column information, right? And then we split by delimiter. Now, split by delimiter doesn't have an equivalent in SQL Server. I think they might have released something like that for either 2016 or 2017, but it's still not exactly the same. So that's something that doesn't fold down. Now, what would happen if I were to move this step down? If I move that step down, and then I move the split by delimiter piece down, okay? Is it still full? Let me clear this out and force it to make sure it's. Okay, it looks like it might actually be smart enough in this case, despite, and that might be because of the whole lazy evaluation piece. But generally speaking, there's certain pieces that if you do them, the parts after that can't be folded down anymore. So, trying to think. Okay, I wonder if it's because it's a generated column. Let's try something different. So we're going to get rid of this entirely, and we're going to split something that it's not generating. Right, so we're going to say this carrier tracker number. Okay, so we're going to say we're going to get rid of that. All right, so right now we've got the only thing we've got is just a simple filter. So let's see if we can properly break this. So we're going to take this piece. Let's actually, yeah. All right, we are going to take this carrier tracking number, and then we're going to split it. Okay, so we've split that up. And so let's see if then if we add a filter. So I want to filter by anything less than 55,000. Okay, so now I'm going to, okay, you can see before when we were, well, actually I think it was just gathering information about that. Okay, so let's clear this all out and see if we properly broke it or not. Okay. Huh. Okay, so it looks like it's still being smart enough in this case to actually push down some of the stuff, which is really nice to see. I don't know if that's a recent change or if there's something with that, the way that it splits the stuff. But my understanding in general is there are certain things that break folding and that it won't fold past that level. But in general, yeah, good.
Sorry, go ahead.
No. I was just recapping, but the recap is basically what I'm saying is PowerQuery can really take advantage of certain pieces of functionality with the SQL engine and fold those down, but you really want to have those as close to whenever you're grabbing the SQL as possible. Sorry, go ahead.
Oh, yeah, before I forget, when you split the column, say like there's one dash, you can split based on that. What if your data has like, you know, dash, maybe even comma in there? When you split, how are you gonna make it know which one to split?
You can tell it the first or the last or here. So let's, and then I see there's some questions in there I'll get to in a second as well. So let's go ahead and clear this out. So if I go to split column, I can say I either want to do the first one, I want to do the last one, or I want to split it each of them. There is also an option to do, I think it's, let me see if I can find it here. There's like split between values or something like that. I think that's probably under transform. It's like get between values or something. Okay, I'm having trouble finding it, but if you need to find something that's like between parentheses, for example, oh, here we go, text between delimiters, right? So you can do something like that. I don't know how well that works if it's the same, but it has some advanced options here that you can see. So there are some things you can do. To answer some of the questions that came up, the first one is, can you compare Power BI and Python, which is more powerful? So Python, by far, is more powerful in the sense that it's a general-purpose programming language. But you know, Power BI is designed for visualization. It's more of a front end. Now, that being said, Python is very common in the statistics community, and you can actually embed R scripts, as you can see here, which is kind of a competitor to Python when it comes to the statistics world. I would say that PowerQuery and DAX are scalpels. They're very narrowly defined tools for very narrow purposes, and when it comes to data manipulation, they're really great. Python makes a lot more sense for general purpose statistical or scientific analysis, or just general purpose programming because it's a fully fledged programming language. Another question is there any way to update Power BI desktop directly instead of downloading the new version? To my knowledge, no. As far as I'm aware, you have to go to the site or click this update available whenever it nags you, and you have to download and you have to run it. There may be some other way, but I'm not familiar with it. Another question is, can we connect to a stored procedure as a data source? Yes. I've tested this out. You can do it. Pretty much anything that you can write as a SQL query. So if I say, you know, get data, and I want to get from get SQL Server, and I go to advanced options, anything that you could write for SQL you can do. You can also use temporary tables. So you could run some stored procedures right to a temp table and then read from that temporary table. It just matters whatever the last basically select is. But yes, you can read SSAS. Another question. When we considered implementing Power BI report, we didn't have an SSAS cube. when is it necessary to consider building a cube as a Power BI data source, and when is it not necessary? So that's a great question. In a lot of cases, you don't need to do that. Like I showed you with direct query, you can read right against SQL Server, and it's going to generate those dynamic SQL queries if you want. What I would say is when you should consider upgrading, so to speak, to SSAS is when, one, you want to centralize your data model, right? IT wants to take a stronger hand in things. Two, you're dealing with a lot of data. Remember, each report in Power BI can only be up to 1 gigabyte of compressed data, and at most 10 gigabytes of data for your workspace. But if your data is, in megabytes or even a single gigabyte, and it's just some basic SQL stuff, or you're dealing with stuff in Excel, there's really no need to get into SSAS. So either when you're dealing with scale or you want more of a centralized development model, those are two really good reasons to look at SSAS. But Power BI in general is designed to be very broadly approachable to business users, end users, even just general BI developers. And so there's going to be a lot of times where you really don't need to venture into more of a centralized kind of model. So glad I could answer that question. I have one other demo, and let me open that up, and that's with the lazy value, the lazy evaluation. So because again, like I said, it only evaluates what it needs to, which is really interesting. So let's ignore that for a second. So I wrote a query that is intentionally very, very slow and inefficient. I have a cross join here. You would never have a cross join. And a cross join is saying, okay, I'm going to take every single row from this one table and join it to every single row from this other. And in fact, I had to limit it to 1,000 because it just takes so long. But if I were to run a live execution plan, you'd be able to see that this takes a long time, and it's expecting a lot of rows. This takes like 15, 20 seconds to run, right? If I do it for 1,000, it's a little bit quicker if I say 200 or something like that. So why do I bring this up? Well, for this Power BI file, I did something interesting. So if I go to the advanced editor, and I should be able to comment some of this out. What I did is I've got a query here, and it's basically running that query, as you can see, and then I've got something else where I'm saying, okay, this variable b, it's the number 2, and I'll explain why in a second, but you can ignore that for now. But if I have this stuff commented out, then if I hit done, it's going to run that query to do the preview, right? And I think it has that information cached, but if I were to hit close and apply, it's going to take a while, right? You can see it's very slow as it's actually reloading the data. So, imagine this being some work that maybe doesn't necessarily need to be done. Now, if I go back here and I go to Advanced Editor, I'm going to leave this part here. But what I'm going to do is I'm going to comment out this stuff. And here I'm just taking the number 2 and I'm saying, okay, turn that into a table and rename it to total. And here I'm going to say, instead of returning the results of that SQL query, which is called source, I'm going to instead return the result of basically this number 2. And so if I do that, so it still thinks, okay, I need the SQL, and then I'm also generating this number 2. And I tell it done, and what did it, oh, it doesn't like my comments. Give me just a second. I left a comment floating. Okay. Okay, so number 2 came back quickly, right? If I hit apply, it takes a second. If I hit refresh, it's practically instant. And so the really cool thing about that is we can see quite definitively that even though I told it, hey, get this information, because it's never actually used, it's never called. And that's really something cool with the lazy evaluation piece, because instead it starts here and it says rename columns. This is my variable name. Well, where do I get that? Oh, I get it here. Well, what do I need? Oh, well, I need something called converted to table. Well, where do I get that? I get that here. Oh, well, what does that do? Well, I need B. Oh, and B is 2. So it never bothers to talk to SQL, which is really neat. We have another question. Normally, how many data import to Power BI will affect the performance of Power BI? So I guess there's a question of quantity of data versus number of imports. The first thing I think about is, okay, if you're reading 250 megabytes of data, how long does that normally take to get, right? I mean, it's not going to be any faster than what it normally takes to pull the data. So bear that in mind, because it still has to load it the first time and compress it all. But you can easily have 5 or 6 different data sources if you want. I mean, generally, you're only going to want to deal with like 2 or 3 for a single report. But you can have at least a handful without any significant impact. Now, once you start like doing a bunch of joins and stuff, maybe that's going to present an issue. I don't know. I also know you can handle millions of rows of data, because the data is generally going to compress really, really well. So for a lot of needs, you can get by with Power BI without too much issue. All right. So unless we have any other questions, I think this is probably a good spot to wrap up. We've got about 7 more minutes. Do we have any other questions from any of the attendees?
Yes. This is Yi. I do have a question about what you just mentioned. You said about the limitation of the Power BI. You said 10 gigabyte per workspace. When you say workspace, you mean?
So what I mean is, let me give me a second. So let me just log into my personal tenant so I can kind of show you, because that's going to be the easiest thing. But you can think of it as a folder is what it really boils down to. Alright, so let's see if I can remember my password. So, you know, here's the Power BI service, and they started calling these apps, but there's these workspaces, right? And so it's basically a folder that holds reports and dashboards and all this kind of stuff, and it's where you're going to be doing your work with managing these reports and all these sorts of things. And I think, let's see, Power BI free versus premium. I think they have a nice little chart somewhere. Pricing. Yeah, no, they used to have a chart that had the sizes, but basically, reports can't have more than 1 gigabyte of data. The way to get around that is to either use direct query or live connections, because you're only exporting the query results, which is nice. And then those workspaces can only have 10 gigabytes of data stored associated with them. Again, if you're keeping it all on-prem and you've got a terabyte data warehouse, then you're fine. You just want to make sure that you control what reports are pinging that terabyte data warehouse, because if someone does a select star, you might be in a world of hurt.
Okay. Okay. Thank you.
Oh, no problem. Do we have any other questions?
So when the data cannot be compressed that well, then it'll affect the storage and also the performance, correct?
Yeah, correct. So you know, the perfect example that we had of that was, we can kind of, let me find it. Sorry, one moment. PowerQuery demo. Okay, the perfect example of that was the whole thing with the incremental, right? Because, you know, it's only 8 megabytes of data, but because of the way it actually stores it, and because these are all unique values, and and it's not able to compress them at all, it's taking up actually additional space, as you can see here. So yeah, it takes longer to read, it takes more memory to store, it's not as able to do aggregations as quickly because it has to go through more data, just all these things. And so it can definitely have an impact. So if you think about it, okay, what's going to have unique values or nearly unique values? Well, that's ID columns, it's GUIDs, it's social security numbers, all that kind of stuff. Now, that being said, you want to have your primary keys in there because you're probably going to be doing joins or something like that. Like, that's fine. But just be aware that the more columns that you add, the less it's going to be able to do the compression, and the more unique values you have, the less it's going to be able to do compression. So that can definitely impact performance.
What would you suggest if, say, like my data has GUIDs, and how is there a way to improve the performance?
Well, so the nice there's not much you can do once it's actually in there, but I would say just when let's say your data does have GUIDs or something like that. Trying to see. Give me just one second. So a good example is, I think, like person.person, right? Like the AdventureWorks database is a perfect example of these kinds of issues, because it actually has like here's a row GUID, here's XML. Now here's the thing. If you're using the GUI to pull in the data, you can in PowerQuery say, you know what, I just want these columns, and it'll only pull in what it needs then, right? So you can avoid pulling in everything and then change your mind later. So that's one thing. Another thing is it really depends a lot on the size of the data, right? So if we think about it, if I do a count star on this person table, right? Even though no one actually uses data like AdventureWorks, but still, if I do a count star, there's 19,000. That's sizable, but it's really not huge. Like we're talking a few megabytes of data most likely, and so that can all fit in RAM very easily. So if you're dealing with less than 100 megabytes of data, maybe more like 50, but if you're dealing with small amounts of data, I really wouldn't worry about it. Or you might be able to do some filtering to filter out data that you're not going to need. So if you're dealing with small stuff or Excel files or whatever, I would not sweat it. It's once you start getting into much larger pieces of data, or you're doing much more complex reporting, that you might start to think about it. And that's honestly going to be a lot closer to the SSAS side, because again, the biggest export you can do is a gigabyte. So there's a good chance that it's not going to be an issue until you start to deal with stuff more like SSAS or very large reports.
Yeah, makes sense.
All right, we're at 10:30.
Yeah. Any more questions from audience? I guess that's it. Great.
All right.
Thank you so much, Eugene, for the great presentation. I already got quite a few people, sending feedbacks, and they really love it.
Oh, that's great. I'm glad. It's always hit or miss when you try to do one of these internals things. So I'm glad it went well.
Yeah, this is absolutely informative and very good learning opportunity. And thank you so much for spending the Saturday night to present for us.
Absolutely. I can't type, but I'm happy to present.
Yeah. Yeah, if you could send me the slides.
Yep.
Yeah, slide deck, and I'll post it on our website, and also post the video on the YouTube.
Perfect.
And send you the link.
All right.
Okay. Cool. Thank you.
No
Thank
problem.
you, everybody, for joining. Thank you so much, Eugene.
You're very welcome.
Yeah. So we'll stop here, and hopefully to see you all next month.
Okay.
All right. I'm gonna stop the recording.